Two identical point charges, small q each, are kept 2 meters apart in air. A third point charge, capital Q, of unknown magnitude and sign is placed on the line joining the two charges such that the system remains in equilibrium. Find the position and nature of the q. We are given two charges, small q, that is positive small q, and this is the other small q. The line joining the two, a distance 2 meters as per the question. This distance is 2 meters. Somewhere on the line joining the two, we kept the other charge, the capital Q charge. It is kept at a distance x from the first charge, first small q charge. Then the remaining distance, we know it will be 2 minus x, because the total distance is given in the question as 2 meters. Okay, we have to find out what is the value of x. That is one part of the question. Later we have to find out what is the value of capital Q and its sign also. So the question says the whole system is in equilibrium, which means the net force acting on this capital Q charge supposed to be 0. What are the two forces acting on that particular charge? We can say force F1 is equal to, magnitude of those forces should be equal, right? Then only they can be cancelling each other. So K, capital Q into small q divided by x square should be equal to K into small charge q and capital Q divided by 2 minus x the whole square. K and q can be cancelled. So we get x square is equal to 2 minus x the whole square. On taking the square root on either side, we get x is equal to 2 minus x, and we get 2x is equal to 2. Therefore, x is equal to what? 1 meter. Yes, actually that charge is kept at the midpoint of the line joining the two charges. We have to calculate what is that capital Q now. As per the question, see, total force acting on this system is 0. So total force acting on the charge at A should be 0. Okay, how many forces be acting on that particular charge? There will be two forces, one due to capital Q and the other due to the small q at the point B. Yes, so sum of these two forces, F1, right, force on charge at A, F1 plus F2 should be equal to 0. We can say F1 is going to be K into capital Q into small q divided by x square, right, plus the other force is going to be K times small q into small q, which is kq square, divided by what? The whole distance between small q and the other small q is 2. So 2 square should be equated to 0. And we already know x value is 1. So it is 1 square. We can keep k capital Q small q on one side is equal to taking the other term minus kq square by 4 to the RHS. Okay, you can cancel. See, k and one of the small q gets cancelled here. K and one of the small q. What are the remaining terms? In the LHS, we have only capital Q. In the RHS, minus Q by 4. So your capital Q should be negative of Q by 4. So